All right, so we are going to talk about the AWS Certified Cloud Practitioner cert. And this is sort of our crash course or prep course for it. The AWS cert, as I've sort of mentioned, is a really useful entry-level certification. Its job is really to get you past the resume screen. You will also, though, learn a lot of really valuable stuff about the cloud. Um, Even if you're not directly using it, so much software engineering is happening on the cloud these days that you will learn a lot of important concepts. And if we kind of poke around and let's maybe Google for AWS CCP just so we can see it. And there's the link for the AWS Certified Cloud Practitioner cert. And this is one of many certs that AWS has. There are a bunch of articles talking about which certs are valuable to get, and this is actually one of the best you can get in terms of bang for your buck in terms of future earnings. So we're going to cover in 4 days the sort of the key things here um, that this cert covers. The Cloud Practitioner cert covers cloud concepts and Amazon Web Services global infrastructure. It covers security and identity tools to manage security and who and what sort of programs have access to what on the AWS cloud. Core Amazon Web Services, AWS services, information about pricing and support. And then, in essence, a little bit about infrastructure architecture, but also about how AWS views its business value and what it calls the well-architected framework, basically the principles by which cloud infrastructure should be designed and the exam strategy. And this material kind of comes from our AI Cloud Ops program that goes much deeper into this domain. So again, the value of this cert, there is some useful knowledge here. The cert's job is to really help you get past the resume screen. The cert itself, unlike the rest of our course, is not focused on building. It's focused on understanding. It is basically a 2 hour multiple choice exam proctored over the computer. You will have to download software. You will have to take off your watch. You will have to point the camera around so the proctor can see that you're not, using anything to cheat. And if you kind of talk to yourself too much during the exam, as I learned through experience, the proctor tells you to stop mumbling because they're worried you might be talking to an AI. Arnold, yes, sir.
Yeah, so I know that we can do that from home. Is there like a facility that we could go to, like a Pearson View or something?
There are facilities as well. Yes. Yes. And when you schedule your exam, there are options to do either. I did mine from home. That was kind of my preferred approach, but I believe there are physical facilities too.
Okay, thank you.
And yeah, and we'll talk about the exam in sort of in the last part with exam strategy. But you will want to schedule your exam probably a week, maybe two in advance so that you can get a time that you want. Yeah, that's a good question. So to succeed at this exam, like everything, I like to think of it as an engineering project. And so we're going to have an exam mindset here because our job is not to master all these technologies and build stuff with them. Frankly, because the very nature of this exam is box ticking, our job is to understand the core concepts so that we have the knowledge we need to easily basically memorize what we need to. And we're going to have a lot of tools to accomplish this. We have a bunch of practice exams. There's a bunch of free resources, and we have some quiz apps that we've built to help you accomplish this. And we've gotten pretty good positive feedback on all those things from folks who have done this before. So we're going to think how AWS wants us to think, how they organize things, excuse me, how they define the cloud, how they organize security models, and how AWS explains pricing. And, part of this was designed so that the idea is, you can explain to a business why they should use AWS, right? Our strategy is going to be simple. We're going to fail fast, which is a great engineering best practice. Fail fast. You learn the most from failure. So we're going to throw you right into a practice exam today. And the goal isn't to do well on that practice exam. The goal is to dip our toes in the waters and see what's out there. And by failing on a whole bunch of questions, as I start studying, right? Like I'm mentally sharpened and prepared to really learn stuff because I know what kind of questions I need answers for. And the way I think about it is when I'm practicing, every question I fail is something I can then go back and master. Because I find it way easier to learn and memorize stuff for a question that I failed than just off the bat. So our strategy is going to be fail fast on early practice exams, build familiarity with the vocabulary, excuse me, and patterns, and learn and lock in some of the high level knowledge that we need. All right. So big picture, we're going to understand the structure and strategy of this exam. We're going to learn about the core categories of AWS services this exam covers, the security responsibilities, um, and identity, our IAM practices, pricing and support, and the AWS well-architected framework. And you guys will do multiple full-length exam attempts. So by the time you take the actual exam, you will have done at least 2 or 3 practice exams, probably more like 4, and probably passed one of them. So there is a lot of stuff covered here, and it is a lot of jargon. At the same time, much of this will be useful because even though this isn't directly related to our personal projects or group projects, once you guys go out into the field, you'll see that pretty much all the software engineering we're doing is happening in a cloud environment in one way or another. And even for full stack engineers or front end engineers, and certainly for back end engineers, some understanding of cloud stuff is basically required these days. So there's a lot of ground that's going to be covered here. And again, it's going to come through repeated practice and it will be a bit boring, but that's okay. And there will actually be a lot of useful knowledge that you get out of this. There are a lot of really good resources here. And the first one I want to point you to is they have an official exam guide document. And I do recommend like downloading and reading through this. And in fact, what I really recommend is using AI to help with this. Um, Now, let's see here. I believe it's Google Colab. You can use any tool that you want for this. Um, if you have an account with ChatGPT or Claude, you can make, they call it a project. And I don't think it's Colab that I want. It is Notebook LM, excuse me. That's what I was looking for. There's too many terms. So what I'm again, you can use any AI tool to do this. Um, the reason I like using Notebook LM as an example is because it has a very generous free tier. But I've done this with Claude. Um, you can do this with um, ChatGPT, as long as you have an AI tool that lets you basically add files to a project or whatever they call it, then you are good to go. So let's go to, and I'm getting a little lost here because they changed all the interface on me. Here we go. And here's one I made before, and we're going to make a new one. And this is where it starts to get interesting. And what I'm going to do and what I recommend you guys do is as you go through this, download relevant files. And in fact, you could, right, copy and upload, you could clone down this repo and upload these markdown files. And we're going to upload these files to the notebook LM. And if we go to downloads and we go to they added, we have the exam guide, and let's go ahead and add it there. And we'll call this AWS. Let's see if I can give it a name. And I think this is good. And basically, I'm going to tell it I am using this notebook LM to help me study for the AWS CCP exam. I want you to help me learn concepts and make quizzes for me. And as we go through this, we can add more and more material to this. And this can be basically our study buddy. And a lot of this we have in our curriculum, and we'll go through it. But the advantage is you can kind of customize and tweak this. Notebook LM has all sorts of interesting features with mind maps, infographics, flashcards, reports. Um, Look, let's just say make me 5 flashcards, and we'll give it just a minute. And it doesn't have a lot of data yet, but we can see here it's created the flashcards. We're going to save them. And let's say now use the flashcards to quiz me. And again, we're going to have a quiz app that you guys can use, but I've found this approach to be really powerful because you can customize it, right? And so this isn't perfect, but let's say give me one question at a time. When I answer, explain if I am right or wrong and why, and then give me the next question because I don't want it to give me all the questions at once. And here we go. So now I've got my own AI powered quiz app and it's asking me a question. And again, my goal here is we're not even worrying about the concepts yet, but I just want to show one way to use these AI tools to accomplish this. And I'm going to just come up with some sort of answer. What fundamental security and compliance model requires both AWS and the customer to share responsibilities? I'm just going to say infrastructure as code. This is almost definitely wrong. And the AI will take a minute and it should give me a response and it explains it and it explains the answer and it explains the question a bit. So it's a bit rough around the edges, but hopefully what you guys can see here is you can actually build up just through prompting and uploading documents and sources, a pretty powerful tool. And in fact, here, if we use their AI interactive quiz builder, it probably does a much better job of doing it manually. So I strongly recommend you all do this as you start going through this process, because I've also found this approach really useful, not just for this quiz, but all sorts of things. And you don't have to use Google Notebook LM to do this. You can use any AI tool as long as it lets you build a project where you can upload files. So I just want to pause and check in and see if folks have kind of questions around this before we return sort of to the exam proper. Rick, yes, sir.
Yeah, it's more of I've kind of done something similar to this before to like get ready for like final exams in college. But yeah, I've never used Notebook LM. I might try to get comfortable with the LM because yeah, it seems pretty powerful.
Yeah. It's and I'll be honest, I actually prefer to use Claude. I'm also paying for Claude out of pocket. But you might be able to do it on the free tier with ChatGPT or Claude. The main thing is having like a quote unquote project where you can add files. I've played around with some of this stuff. For me, like these things, the video overview, I don't really care about, but I know some people really like that. It can read stuff back to you. So if you wanted to like basically build sort of learning podcasts or audio overviews to listen to on the go, it can do that. So that could be quite useful. It can build like mind map diagrams. Let's see, here's the quiz it built. So this is actually quite nice that it's done this for me, right? And it has a whole user interface and everything. So this is actually pretty cool, right? Because now I really have a custom quiz app that this thing is built and it tells me what's right and what's wrong, and I can move on. Um, so I think this might be justify the price of admission by itself, right? So some of these features, like the infographic, I don't know how useful it is, but the quiz, the slide deck, the audio overview, those things I think might really be useful. Um, and to go back to the main point here, there are a lot of resources here. I'm not going to go through all of these now because we're going to go through them in depth later. But this, you know, each of these, as you go through this, add it as a source, right? And you can, I think, paste in multiple links there. And so there's all this stuff that you can add. Um, Now, out of all of these things, there's probably three or four things that are the most important. And let's kind of go through these. So I believe this course, now this one costs money. So if you want to, you can pay 29 bucks for this. You will find some free courses online for AWS prep. There's a whole bunch of stuff out there. Um, there is a glossary of AWS terms. So this is useful in and of itself while studying. And also, again, something that I'm going to add to my AI study buddy, if I can find where I put it, right? Because that's a pretty useful one to have for my AI to just have all of the AWS terminology. Um, there is an AWS Cloud Practitioner Essentials course that is basically that's from Amazon that's free called AWS Skill Builder. And if you want to, you can go through this. And this is probably worth looking at. It's gonna be a bit dry, but it will cover everything that we need. And it says here it's 12 hours and 45 minutes. And again, as you find PDFs or other things, you can drop them into your AI. And then kind of most of all, and let me go to the right link here. And maybe the link isn't there. Um, there is and I will make sure to drop the link for this. And I will come back to this one to show it to you all later because I want to make sure to get to the exam stuff. There is an interactive game that AWS has put together where you actually get to create AWS cloud services. And I'll demo that a bit later. Um, so this site is useful as well because kind of walks through the certified cloud practitioner. Um, Again, there's the AWS study plan that is pretty useful. Um, they have this sort of free learning course here that will walk through the exam. And there are some exam prep materials. I believe there's like one official practice quiz you get here. Um, it looks like there's another pre-test here as well. So there's a number of resources here, and I would recommend exploring through these, and I'll try to explore through them later. And then there's the AWS Cloud Quest game, which I'll demo later, which is actually quite useful. So I got a little lost in the sauce there, but and then there's a free practice exam here through that Exam Pro site. Um, and that is free. So the point is that there's a pretty large number of resources here that we can use to help prepare for this exam, in addition to what we have here in the curriculum. Um, Let me just pause and see if folks have any questions before we start diving into actual content here. All right. Um, let's go ahead and let's walk through these first core concepts, and then we'll take a short break. Does that sound good to everyone? Okay, awesome. So today we're going to focus on a couple different things. We're going to learn about the cloud itself, how it's structured. And we'll be learning about some foundational cloud-related concepts, both more on the business side, like elasticity, and a little bit more on the technical side, like the idea of regions, infrastructure as a service versus platform as a service. So remember, we don't need to build this stuff, but we do know how to describe them. So our goals here are basic cloud terminology, and we see some here: on demand, elasticity, scalability. These different core terms: infrastructure as a service, platform as a service, cloud deployment models. We'll learn a bit about the AWS global architecture. We'll learn about, on the business side, some business reasons for choosing cloud computing, and start getting familiar with the AWS conceptual language. And you all should take your first practice exam later today or shortly thereafter. And down here, you can see we have a link to a practice exam that you can use, as well as a sort of self-reflection prompt to help you think about where to focus your energy next, sort of in terms of studying. And again, here, there's a whole list of resources. And in fact, let me pull this out and we'll kind of put this here, and we'll go to these as we need. So let's walk through the sort of overview and what's cloud computing, and then we'll take a break. And some of this I've already covered with sort of the success plan for taking this exam, but it's good to review and have it written down. And the plan is simple. Attend these lectures, learn the vocabulary, fail fast with the practice exams. And the goal isn't to get stuff right. The goal is to get exposed to stuff. And again, I think it's way more fruitful to take a practice exam, bomb it, and then study to get those questions right than to try and do it the other way around. Create your own AWS account if you haven't, to get a little hands-on, and I'll show you guys the Cloud Quest game later that will help do that. And use the free prep tools that are out there. This exam doesn't go super deep, but it does expect like a solid conceptual understanding. So it will probably take about 30 hours to prepare for this exam, somewhere between 20-ish to 30 hours. Half the time is going to be lectures, but a lot of it is going to be practice exams and quizzes, and we'll show those tools later, and reflection. So let's talk a bit about the exam itself. It's got 65 questions total. Out of them, only 50 are scored. 15 they put in there to sort of collect data to improve the test, and obviously they don't tell you which. You've got 90 minutes to complete it. If you go to a physical location, you've got 120 minutes total with check-in and everything else, and you need a 70% score to pass. Right? So basically, I need roughly 45 questions right, somewhere around there to pass. The certificate is valid for 3 years. There's no penalty for guessing. Every single question is multiple choice and has 4 options. So here are some example questions. What is the pricing model used by AWS Cloud Services? And the answer here is pay as you go. Alex, yes, sir.
So you have to retest every 36 months.
Say that again.
Since the certification is only valid for 36 months, you would have to retest.
Oh, that's a good question. I honestly don't know what you would have to retest for. 3 years from now, you all will be working in the field, and it probably won't be worth it to retest, to be totally honest. If a job required a certification, um, for example, working here at Platoon, the VA wants instructors to have relevant certs. So, I that's one of the reasons I actually got this cert. That said, until joining Code Platoon, I've never gotten a technical certification in my life. So really, the purpose of this cert is to help you get a job. And this cert will do it by giving you knowledge and helping you get past the resume screen. Does that help answer your question? Yeah, good question. Again, this is how tech is a little different, right? If you work somewhere where they require a relevant cert, then maybe you would retest, or maybe you'd go out and get a different cert. All right, how many questions are on this exam, guys? Speaking of questions.
50.
Yeah, there's 50 scored
65.
and 15 unscored. So 65 total. Right. So
Addition hard.
welcome. Right. We can all remember the joys of multiple choice exams where you got to get it exactly right. And this is a great example of AWS exam question as well. And again, this is, this is a memorization question. Which AWS support plan offers a technical account manager? The enterprise plan. If I want a technical account manager to help my business, I got to pay for the enterprise plan. There's not a lot of deep knowledge there. Really, it just comes through practice quizzes and flashcards and memorization. That said, some of the concepts really are valuable. And those are the things related to cloud computing. So cloud computing is defined by AWS as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Right? Can someone give me an example of pay-as-you-go pricing? Tony, yes, sir.
Yeah, I know their security is pay as you go. So as long as the server's live, you're paying for it like by the minute. I think I don't know if it's by the minute or by the hour. I don't know, it's like a fraction of a cent for most of it.
Right, right. AWS EC2 server. And in fact, if I hop over to I had, there we go. It may have logged me out here, but I had the AWS console opened here. And we can in fact see this is mostly cloud spend from the AI Cloud Ops students. And let's see if it's going to force me to log back in or if it's still open. Oh, there we go. I don't think we're seeing any super secret information here. And it's by the second, by the way. All these cloud services, the ones that cost money, AWS is tracking usage by the second, and it's basically fractions of a cent per second. And what we're looking at now is, because I'm on like a management account, how much money we spent in December, I believe. We might not be seeing the DevOps stuff here because I actually would have expected to see more things. This might just be us, but for the whole month of December, and we can see it's broken down in different categories. The virtual private cloud cost, It looks like green is tax, EC2 instances, other, and we can see the breakdown here. I'm surprised we don't see a database here. I think this is our spend. And you can see that like individually it's not that much, but it all can actually really start to add up. And it's all billed by the second, and different services cost different amounts. So that's cloud computing. And instead of maintaining my own servers and having to deal with updating a driver on Linux or the new version of the Linux operating system or the Windows operating system, I rent computing power, databases and storage from AWS, and I only pay for it when I need it. If I don't need a virtual server in the cloud, or maybe, traffic spikes in Christmas, but then it drops after the holidays because we're selling online gift cards, I can spin up some extra servers really easily for the holidays and then spin them down, right? So I can manage demand as it changes. So how did we get here? And we have a sort of friendly diagram that kind of walks through the evolution of hosting. And let's walk through this just a little bit. And let me pull up our nice friendly Zoom annotator tool. So back in the day, maybe in 1992 for pets.com, we'd have a dedicated server. And if I'm running pets.com, maybe the server starts in my basement, then maybe I rent an office space and I actually have a physical computer that's hosting our backend code and really all the code for pets.com. And all it does is host pets.com. And when you go to pets.com over the internet, you are talking, through a bunch of like networking routers and other things. But at the end of the day, you're actually talking to my physical server living in my office. Now, there's some obvious issues here. What if the machine breaks? What if there's a power outage? What if I need to back up data, right? I need to invest resources now for the reliability of this server. And data centers evolved to take care of this so that if I'm pets.com, rather than this machine living in my office and me paying not only for a web developer and a Linux sysadmin, I could pay a data center and they have a physical machine and they have a Linux admin and they worry about backups and power outages and failover and all that stuff. And I just have to have my web developer SSH to connect to that server and write the code that runs on there. This very quickly evolved to using data centers would use virtual private servers where you can use a virtual machine to run multiple servers on it, because maybe pets.com needs many different servers. Maybe we need an internal website for the company so that people can see who works where. Maybe for accounting, they need an internal website. So it's still it's still one physical machine for one business, but we're using a virtual machine to basically slice it up into different virtual machines. The same way if you've ever set up a dual boot for Mac and Windows on a machine, or if you've used a SNES ROM emulator to play games on a machine, you've used a virtual machine. This very quickly evolved into shared hosting, where data centers would have big, beefy physical servers, and they have had one physical machine, but it's shared by many different businesses. And they would use virtual machines to slice it up. So from the perspective of my code, it's got its own virtual server. Excuse me, I'm getting a Zoom setting that I can ignore. I got a Zoom pop up there. I have, from the perspective of my business, it's like I have my own physical server, but it's actually inside a virtual machine. So we have pets.com and I don't know, beaniebabies.com. I'm trying to think of something else from 1992, and cars.com, and buyinsurance.com and so on. And so I have many businesses on one physical machine, right? And this is very cheap. We might get limited functionality, but maybe I don't need a lot of computing power. So we've gone from very expensive, high maintenance, high security to less expensive, better resource utilization, even better resource utilization, but less power, less performance, and maybe less security. And for instance, if I'm a financial trading company, there is no way on this earth that I'm going to share a physical server with my competitor, right? If I'm in a really competitive industry like that, I'm going to insist on almost definitely on a dedicated physical machine. But if I'm pets.com, it's probably not a big deal. And this then evolved into cloud hosting, where I don't, as a business, I don't even need to worry about the data center anymore. The cloud is, in fact, many data centers spread across the country and, in fact, spread across the world. And I have multiple physical machines that run software so they act as one system. And the system is abstracted into multiple cloud services for things like firewalls and load balancing and so on. So it feels in some ways similar to the shared hosting situation. I've got virtual machines and I've got pets.com and cars.com and whatever else. But in fact, we don't know what physical machine these things are running on, and different parts of my service might be running on different places in the cloud. And so we get a lot of flexibility. We get a lot of scalability. We actually get really good security. Cost effective, it can be. It can also be very expensive, and it's very configurable. So that's sort of the evolution of the early days to where we are now with the cloud. And all the software that you will write in a professional context, almost definitely will run on the cloud. Even, in government and the military, they're developing, the DoD has its own cloud. Amazon it offers cloud services for hospitals and healthcare companies with sort of extra layers of security and things it needs for health related data privacy laws like HIPAA. There's a government cloud now. So, for better or for worse, the cloud isn't going anywhere. So let me just pause and check in and see if folks have questions or there's stuff that we're curious about here. Okay, cool. So just to kind of summarize here, all of these things are still around. It's not to say they don't exist, but they're not used as often. And in terms of sort of, for lack of a better term, what the standard is, it's changed. And we've gone from a dedicated server, right, where you have an actual physical machine, but you have to manage it. So you have tons of control. But it can get expensive, not just in terms of server resources, but in terms of paying that high skilled professional to manage your server to make sure you have uptime and you lose flexibility. What if my startup, hits the top page of Hacker News or Product Hunt and suddenly I get 10,000 new users like overnight? We went to virtual private servers. You get better isolation, but still manually managed. We went to then shared hosting, and then finally cloud hosting, where I don't even have in the cloud, I don't even necessarily think about what data center my code is running in. And this is, I know, a poor man's diagram, but the idea is, these are different data centers and they've got all these different computers. And I don't even need to think about this stuff. And in fact, let's Google data center and let's look at some diagrams or let's look at some images. And let's, in fact, Google data centers are pretty cool as well. And Google actually innovated a lot. I think they stuck stuff in a shipping container And it used to be data centers had like big, beefy servers, and Google switched to let's use cheap, inexpensive servers, write software so everything is backed up and can easily run in multiple places. And if a cheap, inexpensive server dies, just replace it. And that's kind of become the norm. And so, right, this is the cloud, is dozens of these data centers, and everything's set up so everything's kind of running in containers in virtual machines. So I don't need to really know or care where my software is running. Now, there's a big asterisk after that that we'll learn more about, but in essence, that's the idea. And this Wired article is actually pretty great. I'll drop this one in the chat if someone wants to repost it. Um, the articles about like Google's data centers actually I find very cool. They put a lot of computing power into there. And in fact, I think both Google and Amazon build their own chips and their own hardware for their data centers now to manage the cost. Right. And so to take this back to AWS Cloud, the cloud is on demand. It's elastic. I can scale up if I get 10,000 new users overnight, and I can scale down. There's agility. I don't have to think about physical hardware or server or resources. I can build and iterate very quickly. It's pay as you go, right? It's literally I'm being billed per second for the resources that I'm using. And there's a global infrastructure, which we'll talk about in a little bit. So these are the key vocabulary terms. Elasticity, right? I can scale up and scale down quickly. It's flexible, it's elastic. Agility, I can. So actually, can someone tell me what scaling up and scaling down means? Because this does have a specific meaning. Rick, yes, sir.
I might be wrong in the context, but scaling up and scaling down, my understanding is most servers in the cloud are now virtual. So adding resources or taking resources away are pretty, like, you don't even notice, seamless. And like if you start getting more users, and you see your CPU or your memory spiking more often, then you can simply log in and tell AWS that, hey, I want 5 more CPUs and 10 more gigabytes of RAM, and it's seamless, almost instantaneous. And if you don't need that RAM, your users go down, then you can actually log back in and say, hey, that 9 CPUs I needed before, I only need 5 now. So can you just give me 5? I don't know if that's answering your question or not.
Yeah, no, I think you explained it very well. And the only thing I would add, just to kind of sum it up, um, and you hit the key point, which is when we're talking about scale, we're talking about size, right? Like small scale, large scale. And for something running on a cloud, size almost always means traffic. So for example, like a buddy of mine worked for an online flower company, and the amount of users they had, the amount of traffic in the system, the amount of orders flowing through the system, the amount of billing flowing through the system shoots up like crazy around the holidays, right? And that's a great example of scale or traffic increasing, right? So number of users, but also like the amount of stuff happening in your system. And to handle that, you're spot on, Rick. The only thing I would amend your statement with is we wouldn't even worry about like adding more CPU. We would just spin up more servers. We would just spin up more virtual servers at that. Because the beauty of like a cloud architecture, and when we kind of learn about containers and stuff later, is that it's way easier. Like if I have like one server here rather than like making my one server bigger, I can only do that so much. And in fact, if like I'm Netflix and all of a sudden a hot new show comes on, um, it doesn't, and I see like, I don't know, 100,000 new users overnight. There's no way I can make a server beefy enough to handle all that. But I could spin up like five more servers to handle that traffic, no sweat. And so spinning up more services or resources, and in this context, when we talk about resources, we're usually not talking about CPU or RAM. Those are resources, but those are resources for an individual computer. If I'm talking about a cloud infrastructure, resources are virtual servers in the cloud, databases, load balancers, and things like that. And so if I'm Netflix and I suddenly get a massive spike in traffic, I'm going to spin up a bunch more servers to handle it. And the diagram that I'm trying to draw here is a load balancer server taking incoming traffic over the internet and distributing it across multiple servers. Right, I'm drawing the arrows here, and it looks a little bit like an octopus, and it sort of is. And that is a big shift, right? It didn't used to work that way because you're absolutely correct. Like if we didn't have a cloud architecture, like we probably would need to increase the physical power of our machines, but that's for good and for bad. Like the advantages of cloud architecture are now like I can think in terms of just spinning up more virtual servers to handle traffic and then spinning them down just as quickly, which is actually pretty cool. So that's elasticity, that's scale, right? Agility, building more stuff. This is about, I don't just need a server. Now I need a database, or maybe I need to deploy more code quickly, or maybe I need to add caching or more parts to my system. So elasticity is about scale, which is about adding more resources you already have. Agility is about building new resources or being able to modify them quickly. And then we've got pay as you go. So this gets into what's called a capital expense or CapEx versus OpEx, which is an operating expense, right? There's no upfront cost or contracts. And in fact, let's Google what is CapEx. So a capital expenditure is funds a company spends to acquire, upgrade, or maintain long-term physical assets like property, buildings, equipment, or technology. Rick, yes, sir.
One thing that you're going over a lot of like expenditures and what businesses need to think about whenever they're expanding and picking a company to go with. One of the things that a lot of people have problems with or companies have problems with are the what is it called? Um, like what they're locked into. And the pay as you go helps, but like a lot of people like put all their services on AWS and then say Google just released a new feature and they're like, hey, I want to move all my stuff over to Google now and completely come off of AWS. And it may be getting better, but what do they call it? Lock-in, where you're
Yeah,
like, all your stuff's on AWS, so you end up sticking with AWS because it'd be too difficult to move everything over to something else. It's
yeah.
I can't remember what they call it, but it's like a
Vendor
lock-in
lock-in.
something.
Yeah,
Yeah,
exactly.
vendor
Yeah.
lock-in. Yeah.
So you touch on a good point because you're totally right. Vendor lock-in is a real and valid concern. However, there is no way in heck that the AWS exam is gonna. I might be wrong. They might ask us about vendor lock-in, but their job is to sell a business on
No,
AWS.
you're right.
Yeah.
Yeah, they're
But
trying to sell their stuff. Yeah.
yeah, yeah, you're absolutely right that that's a real concern. But in terms of like the exam mindset, it's like, oh, no, 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 the cloud is great because we get to reduce capital expenditures. I don't need to spend money on physical servers that are going to be out of date in 3 months. Instead, that money becomes an operational expense for my pay as my go cloud spend that's awesome and flexible and I can scale up. And why would I ever need to leave AWS? Um, but in the real world, you're absolutely right. Vendor lock-in is a real concern. It's just out of scope of this exam. Um, yeah, yeah, that's a good thing to mention. And both things are important. It's good to know about vendor lock-in, and then when taking the exam, it is going to be all about the benefits of the cloud and AWS, right? And so we're going to see questions like
Yeah.
what benefit of cloud computing refers to scaling automatically? Elasticity. And we're going to specifically see that term. We're going to see this jargon show up over and over, right? Cloud deployment models, cloud service models that we'll talk about in a bit. And so we've kind of gone over what the exam expects. And actually, I think that's a great segue into it. Because half of the battle here is remembering like the job of the cert is to help me get past the resume screen and get into an interview. Like my job in taking the exam is to pass the exam so I can get the cert and move on to bigger and better things. And that means like I'm gonna, when I play soccer, I got to play the rules of the game and we're gonna play soccer here and get in that exam mindset. Hopefully this core definition of cloud computing was useful. Do you guys feel like it's starting to make a bit more sense, or does it still sort of feel a little mysterious? Or somewhere in the middle? Rick, yes, sir.
Yeah, somewhere in the middle. Yeah, somewhere in the middle. I mean, some of the stuff is maybe just from doodling and trying things, but some of this is just, maybe from
Yeah,
previous courses in college, but it's a little bit of a review, but it's very helpful.
yeah, that makes sense. And that's how it's going to be with this exam. Like, as best I can, I'm going to try and kind of like illustrate stuff. And I'll show you guys the AWS Cloud Quest in a bit, which really will help. But sometimes it is also going to be, it's going to feel a little like disconnected, and it is frankly an exam of memorization. That said, I think the one thing that I do find helpful in thinking about like the cloud and all this stuff, and let me do a little bit of drawing here, and we'll call this my laptop. All right. And so the cloud is basically we have gone from, you know, a physical server and the physical server is running. Let's just use Django on it as an example. And let's just say like Linux. And then inside Linux, we have Django. And maybe we don't even have a cloud yet, and we just have a data center. And, you know, as a programmer, I know that it's not just about running code on my computer. It's also about running code um, in the production environment, i.e., where the actual live application lives, which in this case is going to be our physical server on the data center. And I know it's not just about me writing code all by myself. It's about my team and the other people, interacting with this code to help develop it. And we start out here. And then we basically go from rather than all of this happening on like one physical server, we might now we have a physical server. And this was the shared hosting scenario where maybe there's two different apps running here on the same physical server using a virtual machine. But now with cloud, and of course our data center has more than one physical server. Right, so let's make two of these things, and we'll make it a bit smaller. And we'll make two, and let's make three. Why not? Right? And let's put our data center in a box. And before the cloud, we might, as pets.com, have a contract with a specific data center to host these things. Or maybe a company that has multiple data centers, so we have a backup on more than one, right? Especially if we're nationwide, or in case like there's a catastrophic crash or like an earthquake in California, I probably want my stuff on two data centers. Now, maybe we start to have more data centers, and maybe we're Amazon and we're building Amazon Web Services, and at this point we now have what we call the cloud, which is basically these networks of computers within data centers, and then this network of data centers. And what we'll look at after the break is how like AWS has something called regions, because it does sort of matter. You get to choose what part of the country your code is running in, though you don't choose the specific data center. So let's take a break. Let's take 5. And then when we come back, we will continue our journey with AWS and cloud computing. And we will talk about, we'll get to the infrastructure in a minute, but we're going to talk about sort of cloud service models and deployment models. Thank you guys, and I'll see you all in 5 minutes. All right, so we're going to look at cloud service models and deployment models. Before we do that, I do want to point out, in terms of some of the resources that we have, there's actually something really useful. So I had mentioned the skill builder and this Cloud Quest game before. With the skill builder, you will have to create an account on it. It is definitely worth doing. Definitely do that. And I logged in during the break. And then if you go to learning plans, you'll see they offer an official practice set for different certifications. And the user interface is a little confusing here, but at some point, there's actually a way to pick the cert that you want to get, and go to the skill builder page for it. So here's the skill builder page for the CCP cert. And here's exam prep. Here's exam prep, more practice set, a sort of cloud practitioner essentials course. But somewhere in here, and if you don't see it here, you can always search for it here with Cloud Quest, AWS Cloud Quest. AWS Cloud Quest, Cloud Practitioner, the free one. And this thing is awesome. And I've actually pulled it up over here already. It is on the surface sort of a cheesy game. I don't know. Can you guys hear this music that they have here right now?
Yeah.
Yeah.
Oh,
So
oops.
this looks cheesy, right? And it is cheesy, but we're going to give it a minute to load. And the reason I like this is because the game has you spin up actual AWS cloud resources. So you get to get hands-on. And it actually does a great job of walking through the sort of core scenarios of AWS infrastructure. And let's turn off this music now before it drives me mad. So they've built this game, and it's this whole 3D interactive thing. But what matters is that you have different quests and things that you can accomplish. And all this stuff, I honestly never used any of this stuff at all. But what matters here is, let's see, I don't even know how to go to the area. Yeah, I don't even want this. Somewhere in here, and forgive me for getting a little lost in the sauce in their user interface. So I promise there is actually stuff that we can do. Here we go. I was getting confused there. Let's go to the first assignment here, which is, let's go to highly available web application. And so you'll see stuff like a travel agency wants to make sure their web application remains available to customers, even if some components fail. On completion, you'll be able to design highly available web applications, blah, 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 blah. But the value of all this stuff and the cheesy 3D game is it's going to actually walk us through building a real web app architecture if I can just figure out where to go to do this. And there we go. Forgive me. All right, there, we can finally get to the part that we care about. So here we go. Now we finally get to what we care about. And the reason I like this is because you get to spin up actual AWS services, not on your personal AWS account, right? So I don't have to worry about money or anything else. And so we're getting through here. It took a minute, but we're finally kind of getting to the more interactive part. And it's going to walk us through this theory, hands-on tutorials, and then we actually do stuff. And it's going to also use all of the jargon that we need to care about for the AWS CCP exam. So you might skip through a bunch of this learn stuff and just get to the practice part. But you can see here, this is where it starts to get useful, right? Because now we start to have actual architecture diagrams and talking about what we're going to do. And, there's a whole backstory here about the islands system and whatever. But really, we're learning how to spin up some AWS EC2s and a little bit about the AWS global architecture. And if I wanted to, there's a whole video on the
AWS
AWS
Global Infrastructure Overview
that we could
The
watch
AWS
that we're not going to watch now. And this kind of walks us step by step through steps and concepts. And here it walks us through what to do in the AWS console, along with some details. And this is why I like this game, right? Because now that it's walked through all of this, I actually have to, I think it will actually spin up an AWS console for me to do this work in. And it's still provisioning it, so it hasn't been built up yet, but it will eventually get built up. And it looks like I may have skipped a step here, but that's okay. I think you guys can kind of get the idea. And somewhere in here is the button to actually open up the AWS console. So I realized that it took a couple clicks to get through this stuff. And it is a little bit cheesy, like all the stuff they've put around here. But I think this part is actually quite useful, this sort of like step-by-step walkthrough of how to do things. Because we're not going to need to actually spin up all these services for the Certified Cloud Practitioner exam, but I learn much better by getting hands-on and actually doing things. And so if you guys do as well, then I think this is a really great tool, because rather than playing around on your own personal AWS, not being sure what to do, certain services might cost a couple bucks on the credit card. In here, you can do it all, and you actually like learn some good sort of cloud DevOps fundamentals along the way. And there we go. And now this is the AWS console that it's created for me, and where I could actually create EC2s or whatever I wanted according to the particular lesson. Right. So I would create EC2s or whatever resources it wants me to here. And then when I'm done, I would go ahead, and I believe it wants me to like, yeah, it wants me to paste in those instance IDs, and then it will actually check my cloud environment to make sure that those are created correctly. So I realized that took a couple bits of clicking to get through. But again, I think this is really useful, because the studying for this exam is going to have a lot of dry stuff. There's no way around that. There's going to be a lot of flashcards and quizzes and reviewing of notes. But if you want to get your hands dirty to kind of help go deeper into some of these concepts, if that's how you like to learn, then I think this actually does it quite well, even though it's not perfect, because it walks you through what you want to do. There's a lot you learn along the way, and you can actually do it, and then it'll validate you to tell you if you've done it right, and it covers a whole lot of stuff. So hopefully that was useful to see. Do you folks have any questions about that Cloud Quest game or anything related to that? Rick, yes, sir.
Yeah, maybe it's in the video, but how exactly did you get to that game? Was that logging into AWS?
Yeah, it's a bit of a pain in the butt. You have to go to Skill Builder, and we have a link here in the main README for this section. But if
Okay.
you also just Google,
I
like,
could probably figure it out.
yeah. So basically, this AWS Skill Builder is going to sort of be your home base, because this is where you can also get the official AWS practice exams. And so what might be, I find it easiest to just, as you saw, Google AWS Skill Builder, CCP, and then frankly, I just filtered for Certified Cloud Practitioner. And you can see here, there's this Cloud Practitioner Essentials course, which is going to be a bunch of videos, and that can be worth doing. Then we have the Cloud Quest game, and that's what I just showed you. And you can see here, there's an official pre-test, so a practice exam that you all should do soon. And they have an official practice set. They have some prep summary, and then they have like specific material for different parts of the exam. And I do recommend going through all of this and uploading it into your AI study buddy. But the main thing is going to be the practice exam. And as I said, I find this Cloud Quest game useful. All right, let's switch gears. And again, I know today's a lot of talking and a lot of covering of ground. I kind of want to lay everything out here to set you guys up. Let's talk a bit more about like actual AWS cloud stuff. We got to talk a little bit about what they call cloud service models and deployment models. AWS organizes this stuff in what it calls different layers: infrastructure as a service, platform as a service, and then software as a service. And let me just ask real quick, what's an example of software as a service? Rick, yes, sir.
The most hated software as a service I can think of is gaming. To to play a game now, you have to pay a monthly service to play a game, which is one of the things I hate with how the gaming industry's gone.
Yeah, absolutely. That's a great example of software as a service. I saw another hand as well.
That may have been me.
Oh,
I fumbled the button. That may have
yeah.
just been me.
So there's a bunch of examples. In fact, right now, TLDraw that I'm using in the browser is a good example of software as a service. Um, Google Maps is software as a service. Um, Salesforce is software as a service. Anywhere where basically, and in a lot of ways, the Pokey API is also software as a service, right? The software is an API, but it's being provided to us. And so really any software could be user facing or an API set, which we can use over the internet and not have to think about. And so in some ways, a great example is, right, Netflix, like online gaming, Salesforce, Pokey API, and so on. And the idea, of course, is that we're paying for this service. And this is kind of the top of the pyramid, right? Because below software as a service, we have platform as a service, right? And we'll talk about that one in just a sec. So for AWS, what it cares about is what does AWS manage? If I'm paying for AWS, what do I get? Right? What do they take care of versus what do I manage? And the key thing is how much responsibility do I offload? Right? How much responsibility do I offload? So with software as a service, I manage nothing, right? It's a fully managed solution by a web app. And let's go ahead, in fact, and let's drop this into our diagram. And let's just put our diagram here off to the side. And just to kind of add this in, and we'll drag down the platform as a service. All right. And so with software as a service, I manage nothing. It's fully managed, and we have a couple examples here. The next level would be a platform as a service where I manage just the code. AWS manages the runtime, it manages scaling, it manages servers, it manages infrastructure. So this is more than just an EC2, right? This is sort of a middle ground that we haven't seen yet. And we'll talk about infrastructure as a service, which we've sort of seen with the EC2 in just a second. And if you think about managing your own dev machine and all the work that goes into it with InstallFest, and imagine that someone just did all that for you, right? So that the machine was already set up and ready to go and it had everything that it needed, right? That would be an example of a platform as a service where all you have to think about is just the code. And then finally, we have infrastructure as a service, right? And this is like what we all do with our own local dev machines, right? Because it's really our programmer's tool bench. And I have to manage my operating system. I have to update my operating system, or I have to update Homebrew or apt-get or WSL2, the version of VS Code, what version of Python I'm using. I have to update pip. I have to deal with the new version of NPM and the applications. In the cloud environment, this means something very similar. And what does AWS manage? Well, it manages the hardware and the virtual machine and the networking. When I spin up an EC2, I don't have to worry about if the hardware dies. I don't have to make sure that it's got power. I don't have to worry about the virtual machine. I don't have to worry too much about connecting my EC2 to other things in my cloud network. Amazon does all this for me, right? So I get a lot more control and a lot more flexibility, but I do have to do more work. And if I can just grab what I want here in TealDraw, we can have our platform as a service diagram. And we'll just draw a new one. So infrastructure as a service is sort of at the bottom of our layer here. And there's one important thing I want to point out here. We haven't really seen this, but in this platform as a service stuff, with services like Elastic Beanstalk, AWS will do a lot of the work that we had to do manually on our EC2, setting up Django and other things. And in fact, if we Google Elastic Beanstalk, we'll see it's a platform as a service, simplifies deploying and scaling web applications by handling the other underlying infrastructure, like provisioning servers, EC2, load balancing, auto scaling, and monitoring and logging. So developers just have to focus on code. You upload your code, and Beanstalk automatically manages the resources, and it provides features like health checks, automated updates, and options for high availability, right? And we can read about it here. And so, I might find a one pager on AWS Beanstalk to add to my AI study buddy as I'm building this out. So you can imagine, how much time this might save you in terms of deploying to AWS. Now, of course, AWS Beanstalk costs more than an EC2 to use. And in fact, if we look at pricing, oh, I apologize. I'm actually totally wrong. There is no additional charge for AWS Beanstalk. You can just go ahead and set it up and use it, but then AWS Beanstalk is spinning up the EC2 and so on. So AWS can offer more than just this infrastructure that we've seen with an EC2 or virtual private cloud. It can do a lot of the work of basically setting up a system for us, right? And that's a platform as a service. So all I have to think about is code. With infrastructure as a service, I have to think about the operations system, the OS. I have to think about spinning up EC2s and so on. So we have a nice table here, just visualizing who does what. And this is a big part of the exam, is talking about this who does what part for infrastructure as a service versus platform as a service versus software as a service, right? So infrastructure as a service gives me control, but requires setup. Platform as a service is easy to deploy, but is less flexible. Software as a service is totally hands-off. There are also what's called cloud deployment models, which is where your services are hosted and how they're isolated. So on a public cloud, AWS is managing the infrastructure. There's shared hardware. It's cost effective. It's scalable. And this is the default for AWS. If you want, you can have a private cloud, right? And in fact, if we go back to our cloud diagram here, in essence, what's happening on a private cloud is I'm the US government and I have some sensitive information and I don't want it to be like physically co-located with other stuff in a data center. So maybe what happens is AWS takes two of these data centers and puts them in a private cloud, right? And so the only person using this private cloud is this customer who's purchased this private cloud. So you get dedicated hardware, isolated environments. You get more control for compliance and security reasons. It costs more and it is more complex. And again, governments or companies with strict requirements, I think like financial trading companies are always a good example of this, are use cases where you might see a private cloud. Hybrid cloud is a little weird. It's where I might have some physical servers in my company offices or my own data center, but I want them to be able to talk nicely with my cloud services. You're often using this if a company is migrating. Maybe we have a bunch of mainframes in a basement and we're migrating to the cloud. And so during this process, which maybe it takes months because it's a big migration because we're a big bank, we're having a hybrid approach. Or we have some specific requirements. Maybe there are some laws requiring like where our data lives. So again, an example of this would be we have a database running on a physical server somewhere, and it's synced to a database in the cloud. So let's hit a couple practice questions here. Which cloud model gives full control over the operating system and the network? Infrastructure as a service, right? That gives us full control. What about software as a service? What's an advantage here? There's no infrastructure
Nope.
management required. Yeah,
Yeah.
no, and I know we're tired, guys. I totally get it. So what type of cloud model allows a business to run on-premise and an AWS, the hybrid cloud?
Hybrid.
Thank you. What service model requires the least customer responsibility? Software as a service, right? As a customer, I don't have to do anything. And what AWS service is most aligned with platform as a service? Elastic Beanstalk is one example. So we've covered a lot of ground here. We've seen these terms: infrastructure as a service, platform as a service, software as a service, how they're going to show up on the exam, the responsibilities of each and where they fit in, and then some trade-offs between public, private, and hybrid clouds. And again, I know it took me a minute to go through that AWS Cloud Quest. I highly recommend it. Once you get set up in it, it's actually, I think, a way more interactive way to learn this stuff. We do have a bit more ground to cover. I know today has been a bit of a long day. Why don't we take let's take 5 and then we'll cover the rest of it. Thank you guys, and I'll see you all in 5 minutes. All right, so the third part of today's lesson is on the AWS global infrastructure. The cloud is still on physical infrastructure, right? Even though it's abstract, it still lives in data centers. Amazon has a global data center network. It's organized around the world. The buzzwords that we need to pay attention here, and this is also true, its data center network is organized for redundancy, fault tolerance, and low latency, right? And as I'm doing this, I might decide, you know what, I need to look some of these terms up. Like, what is redundancy in networking? Because these terms are going to show up, right? Redundancy, fault tolerance, low latency, these terms have specific meanings, right? And redundancy is building backup components into a network. Say having two copies of a database in case one goes down, or two data centers in different parts of the country in case there's an earthquake in California. And so I might go to my notebook LM and go here. I might say like, what is fault tolerance? And we'll give the AI a second, and it probably can't get it from the answers, but it's still got Google Gemini AI. So let's see what it says here. So it gives us a whole bunch of information here. And it's talking more about it. And I might want to tell Colab to be a bit more succinct. Note that it did find all these other AWS things to relate it to. And so in fact, if we just Google what is fault tolerance, so fault tolerance, just even in general, means something can keep working even if parts of it fail, right? So that a system is designed so that it can keep working even if parts of it fail. And so the cloud has been designed that way. And then low latency, and latency also has a specific meaning, right? And it's how long something takes to happen. So when I send a request from my browser to Google's server, how many milliseconds does it take for Google to send a response? And that would be its latency. And in fact, if we go to the AWS glossary, we can probably find these terms in here as well. And in fact, we can download it as a PDF, which is great because I could now upload it to my my notebook LM. But if I go in here and let's just search, if we just go to L, then they might not actually have latency in here. So these terms are going to come back up, so I would flag them. So let's talk though about how AWS has designed this network to accomplish these things, right? And now we have to introduce some more jargon, regions, availability zones, and edge locations. So, and let me go ahead here and let's just pull up the TL draw and we're going to do, we'll come back to TL draw, but we're also going to pull up the Amazon docs, and you'll find that Amazon has tons of docs on all of these things. So a region is a huge geographic area. It contains a bunch of data centers. Regions are isolated so that there's fault tolerance. There's more than 30 worldwide. This is the key bit. Each region contains at least 3 availability zones, right? So I would write that one down because that's going to show up on the exam, I can pretty much guarantee. Each region includes at least 3 availability zones. When you launch a service, you usually choose a region, right? And just to kind of visualize here, we can see some of the AWS global regions. Note there's AWS Government Cloud in the US East region. There's the US West region. Canada has a couple regions. Mexico has regions. And then if you go all over the globe, there's different regions, right? And so each of these dots covers a big chunk of space that's going to have at least 3 data centers. Most of the times, it's usually like the US East region. I think that's the default one when we create new stuff in AWS. Rick, yes, sir.
Yeah, I'll just say, I mean, that's all good. Sometimes you can get mirrored or whatever, mirrored servers, I guess you'd say in other regions. But one thing I've seen problematic with regions is like I think there's a Chicago region east or whatever. But if like say somebody from California is trying to bring up your website, the latency may be more for someone that lives further away from the region. Like if somebody here in Chicago brought up my website, it would pop up no issue with very low latency, but then you get further away from the region. Um, and it costs more, but you can get like, I think it's called mirrored servers. So you can mirror your server to a region out in California so that the latency is less for anyone that tries to log in over there.
Yeah, yeah, absolutely. That's a great point. Like you know, if I'm like a startup that's just launching, I might not worry about it too much. But if I start to get lots of traffic, I might want my whole system running in two regions so that people in California, like if I'm Netflix and I'm getting tons of traffic, I'm gonna want people here and here. And I'm gonna want my system running in both these regions to reduce latency, right? And then if I want customers in Europe and I'm Netflix, I'm definitely going to need my system running in servers over here to help reduce latency. Um, right? And so along with scaling, getting more traffic, more people, depending on what's happening, we have to then start thinking about latency and where are these people coming from, and do I need to have my system running in multiple regions? Though we'll see in a minute, edge locations sometimes offer a way to support this. And as you said, there's a lot of techniques and approaches. Regions each have availability zones, and that's just one or more data centers. So an availability zone might just have one data center. A different availability zone might have two or three data centers. It depends. Each data center has independent power, cooling, and networking, right? So this is our fault tolerance. If I have my whole system running on two different availability zones, then if one data center goes down, the other should still be running, right? If one availability zone fails, others remain available. So we've got fault tolerance, and kind of similar to what you were saying about mirroring regions, a lot of AWS services support multiple availability zone deployments. Finally, we have something called edge locations. And this is to sort of tackle the problem that you mentioned, Rick. I'm so sorry, man. I don't know why my brain is failing me there. Um,
I think you're just tired and still a little sick.
Yeah, I think that is exactly it. They're running on either too much or not enough coffee. Um, because the only other Rich I know is our career services guy, Rich Luby, and you guys are both awesome, but I don't know if you guys have anything in common other than the first three letters of your name. Um, so putting my whole system in two different regions might be a lot of work, but an edge location is basically rather than like a whole region with an availability zone with the data center and the fault tolerance, if my goal is just to make sure that, if my main system is running on a region here on the East Coast, that people on the West Coast can access my data more quickly, maybe I don't need that whole reliability and that whole infrastructure. Maybe I just need a bunch of little servers peppered around here, right? And so edge locations are basically little servers peppered around. And I don't get the same guarantees about fault tolerance and stuff like that. But the job of the edge location servers isn't to back up my data, it's just to help stuff be faster so that someone in California, rather than having to go all the way here to get the data and goes back, well, they can go to an edge location. And so it's this whole other network of servers. And in fact, I think it's Cloudflare. Yeah. So this is provided as a service, and Cloudflare is one of the big providers. Um, this is often called, I'm not sure if it's quite exactly the same, but it's often called a CDN, or a content delivery network, right? It's a global network of servers that stores copies or caches of website content, like images, files, videos, and so on edge servers that are closer to users, dramatically speeding up website load time. And if anyone has ever used, like, for Bootstrap, it's pretty common that a lot of these UI frameworks that we like Bootstrap or React, have an official CDN through this service JS Deliver. So rather than maybe like installing Bootstrap in my source code, I might just include the link to the CDN here, because there's tons of little edge servers all over the globe that will have Bootstrap, and then it gets loaded in the user's browser, then it's saved in the user's browser. And it looks like this CDN is JS Deliver, right? And because this is such a common use case for like JavaScript code or CSS stuff, JS Deliver is a CDN designed specifically for that. And if you look at React, like React has a CDN as well, and some official links. Now it looks like they're on the legacy docs, but that's okay. Um, and this is from some other surface. It looks like it's called Unpackage, which is also a global content delivery network or CDN service for JavaScript stuff. So AWS is not the only service that offers these edge locations. It's sort of a common need, right? And so your edge locations are closer to users than the main regions, and they're used for caching and delivering stuff. So edge locations are pretty cool. So we have regions and availability zones for fault tolerance and reliability, and for scaling. And then for scaling and to handle latency, we have edge locations, right? Edge locations improve performance and latency, not durability or failover. So we have here just the diagram kind of summarizing these things. And then just a nice little table to help us remember this, right? Regions have availability zones, and then edge locations are sort of their own separate network peppered over that's there really to help with performance. So what is a region? A geographic area with multiple availability zones. In fact, I think it's at least 3. What's the purpose of an availability zone? Fault tolerance. We get fault tolerance. Rick, yes, sir.
No, I thought you were asking the question to the class. I was just raising my hand.
I'm half asking. I know people's brains are wiped. These questions are a little bit of gimmies, but they're also good. So which service uses edge locations? This is a good one, guys. This one will definitely be on the exam. So CloudFront. We are going to learn that AWS has tons of services. CloudFront is Amazon's CDN, or content delivery network, right? So if I'm using AWS, I'm probably not going to use Cloudflare or JS Package or whatever. I'm going to use CloudFront, and this is a CDN, right? So this uses the edge locations, right? And as it says here, reduce latency, cut costs, all this other stuff we don't have to worry about as much. You can do some pretty fancy stuff with CDNs these days and edge locations. But the main thing I want you guys to take away from this is AWS CloudFront is a CDN, a content delivery network. It's used to improve performance and latency. Like, say, if NBC wants to have the Super Bowl live streamed and have really good performance, and that uses edge locations. And finally, we haven't talked about this a ton. Some AWS services are global, some are regional. Not every single service is available in every single region, though many are. As you can see, there's a ton of AWS services. So, and some services are like it matters what region. If I'm spinning up an EC2, it's got to be in a specific region. But for IAM, which is the identity management, does it matter what region I'm in? It does not. Because the whole idea of identity management is for my whole AWS cloud and account and organization. I can manage the identity of all the users on that system. I don't want that to be tied to a specific region. Like if I make an EC2, it's got to be in a specific region. But identity management is global. So we've now got an understanding of AWS's physical layout, how they achieve high availability with these availability zones, what edge locations and what CloudFront are, and global versus regional services. Let's tackle the last thing we have, and then we'll wrap up for today. And again, I know that today was a big day, and thank you guys for being patient with me, and the future lessons will be more succinct. So this one is going to get into a little bit of the business use case. This is a little bit more jargony. There is some value to be had here. Basically, AWS says the primary business value of using the cloud is these four things, right? These terms: agility, elasticity, flexibility, variable cost. These terms are going to come up a lot on the exam. So as annoying as it may be, it's good to learn them. Also, while this won't come up directly in technical interviews, it is good to be aware of this and to start thinking in these terms. So agility, I can quickly experiment and deploy and iterate without hardware delays, right? If I want to prototype some new code on a new server, I can spin up that EC2 right away to test this new application out. Elasticity, it's Christmas season. We've got tons of people ordering flowers online. As I said, a buddy of mine who is sort of a mentor and a peer was a senior software engineer here for the Books online flower delivery, which is pretty big. And around like holiday season, that was when they saw peak traffic. So I can spin up a lot more servers to handle demand during the holiday season. Flexibility, I can mix and match. I can use Elastic Beanstalk if I want a platform as a service, or if I want or need to kind of get deep in the guts of things, I can spin up my own load balancer and my own EC2 and my own database. And then variable costs, right? I'm not paying a capital expense of a physical server that I own as the company and maintain and is taxed one way. I'm paying an operational expense. I'm just paying for what I use. There's no upfront investment. If I'm using it, I'm paying for it. If I turn it off, I'm not paying for it because I'm no longer using it, right? And it probably gets taxed differently as well. So variable cost. So these concepts are really important. They're going to come up a lot. And the best way to master these is simply to do a bunch of quizzes. As I mentioned, I think the Slack quiz app that we've built is really useful for this. If in a message to yourself or in any channel, you just do start quiz space number of questions, it will build a quiz that you can go through here. And I will share the link to the source code for that later for people who are interested. So we have this nice diagram here that just goes over these cloud benefits again of agility, quickly deploy new things fast, elasticity, scale up, scale down, think more databases, more servers, flexibility. I can run some jobs on premises. Maybe I have sensitive data that I want to stay on premise. Maybe I'm migrating to the cloud, but part of my business needs to stay on premise. And then variable cost, I only pay for the computing resources that I use. So you're going to see a couple phrasing patterns that are pretty common. Which AWS benefits help you quickly test a new business idea? What's the answer here? Agility, right? What feature allows an application to scale up on Black Friday and back down afterwards? And that's going to be elasticity. A company wants to move a few apps to the cloud while keeping others on-prem. Which benefits allow this? Flexibility. How does AWS replace capital expenses? Variable costs, pay as you go, right? And again, this is why just diving into that practice exam is the way to go with this stuff. And really, the best possible way to study for this is, I think, just reps and sets with quiz questions. And what I do is I do a quiz, and then I make sure, though, like when I go back over the questions that I got wrong or right, anything I didn't understand, I dig into, right? So even if I got a question right, if some of the like options, some of the wrong answers I didn't understand, I would actually spend that time going into the wrong answers. But I always do it by starting with an actual question that I did. So, which benefit allows you to scale based on demand? Elasticity. Which benefit allows you to deploy quickly without buying hardware? Agility, right? A company wants to use multiple and on-prem tools. What benefit does this refer to? Flexibility. What's another name for variable cost? Pay as you go, right? I was actually thinking OpEx here, but pay as you go. All right. So guys, the next step here is going to be the practice exam, right? We've learned about kind of these key terms. You're just going to want to dive into the exam. And again, the goal is not to get the questions right. The goal is just to see a bunch of questions and then start going back over and reviewing them. And we have this sort of like post-exam reflection prompt. And this is useful because this is how you target your studying, right? You figure out, where were my strengths? Where were my weaknesses? What do I need to put more time into studying? Start to notice like the categories and the patterns. Is there any wording I need to watch out for? Like what do I want? What action do I want to take? And sort of like, what's my self-assessment so I can kind of track my progress, right? So, and this is just for you. All right, guys. So again, to recap, and forgive me for kind of hopping back here. Take the practice exam, do the reflection prompt, and then also make sure you sign up for the AWS Skill Builder account. You'll want to create an account and start that Cloud Quest game, which is actually quite good, even though it's, 3D user interface is a little clunky, because then you can get hands-on. And then finally, build up your Google Notebook LM, right? Because I actually think this is a really powerful tool in the toolbox. And you can just keep adding to it as you go. For instance, we can add the glossary that I just downloaded. And so as you're going, you can add this and you can refine it. For instance, you can tell it, always give me short and succinct answers that are easy to digest. And I'm pretty sure there's a way, in fact, to add that to the sort of system context prompt here. I'm just not sure how to do it in the UI. But so you can kind of tweak and refine your AI tutor, and you can have quizzes here to answer questions and save things as notes and build up your study buddy. And I think that will help a lot as well. So hopefully this is useful and a good start. And thank you guys. And let me go ahead and just stop our recording.